Hello, everyone. My name is Kevin. I'm the training coordinator with the Association of State Floodplain Managers. I'd like to welcome you to our presentation today. This is going to be part 2 of a two-part series, and today we're discussing the Agentic Workflow for flood modeling and forecasting. So thank you all for joining us. If you were with us on Tuesday for part 1, welcome back. And if you happen to miss that one, as I had mentioned, that was recorded and we'll be making that available to you. So hopefully you can follow along with us today. And speaking of recording, this one is being recorded as well. So both of those are going to be available to you later on if you want to reference that for any reason. A couple quick notes before we get started. Just want to mention to everyone joining us here that we've got a pretty good sized audience today. We can't unmute lines and allow for kind of cross-talking and things like that, but we do want you to interact with us. So if you have questions, if you have comments, go ahead and find the Q&A feature here within the Zoom software. That's not the chat panel. It's a separate area called Q&A. If you have questions or comments, drop it in there, and we'll take as many questions as time allows at the end. Final note just on credits and certificates of attendance and things like that. This is eligible for CECs for CFMs, and if you hang out with us the whole time and you participate, you will be earning that credit. So that'll get applied to your record automatically in most cases. I'll also be sending you a certificate of attendance, though, in case that's missed for whatever reason, or you have another certification you need that for. You'll get that certificate of attendance from me. This is going to take me up to 2 weeks to turn around. So you'll get an email from me. Again, my name's Kevin. I'm with ASFPM. You'll have all that certificate and credit information, as well as any additional promise follow-up that may come from the meeting today. So be on the lookout for that, but I appreciate your patience on that front. Okay, so that's a lot of admin items, I know, and we've got a great presentation, so I want to get into it. I'm going to first turn it over to Tyson James with the AI Committee. He's going to tell us a little bit about our presentation and the speaker. So Tyson, go ahead and take it away. Thanks very much.
Welcome out, everybody, to the second part of this webinar. Today is the explorative lab. So this is where we're going to get our hands on, and I'm hoping that it will build your confidence in AI. You are also welcome, if you want, to simply sit back and watch it. You do not have to participate in it or register for the NEAR account or do any of the activities. The plan for today and the agenda would be, it's probably going to be about 30 to 45 minutes of this lab. If we finish earlier, we can move on to question and answers. And then the last few minutes, I'm going to leave open to everyone to fulfill the survey at the end. So to start off, I'm in the chat, I'm going to put the link. And if you click on this link, it will take you to a GitHub page that has all of the class materials for today. So it has the tutorials, step by step. The first thing on there is that you should have already registered and verified your NEAR account. So if you have not done that, do it right now, ASAP. And then second, I just want to kind of mention the reason we have a space between these webinars, an extra day, is to give you that time to come prepared to the webinar. So moving forward and with future webinars, there might be more that's required. Just kind of a foreshadowing there. And then I have some of my own kind of housekeeping here. So because of the size of this audience, I want to set some of the expectations here up front. We're going to perform rather simple models and workflows. And the reason is I want to cater to the entire audience. Some of the audience may not be technical, they may not be modelers. And so I want to give them as much of a potential to accomplish and complete the task that we're going to be doing today. But with that said, if you fall behind, once again, because of how large this group is, we cannot attend to you at the expense of the entire group. But I don't want you to suffer in silence. So please leave a comment in the chat or the Q&A, and we will assist as many as we can. And then with that, know that these are being recorded so you can rewatch. And then there's also communities. So if we can't address it on this webinar, afterwards or in the coming weeks or months, feel free to join on Flood Zone. I'm going to drop that link as well here in the chat. And then I'll also drop the link to the LinkedIn page. So if you have any, I'm going to have to redo that one. Um, there we go. So if you're getting stuck, I'll look at these after the meeting and try to help you guys get through it. If you finish early, if you're ahead of the group on the other side of this, feel free to go and explore other tools and start looking around and putting those questions in. You can reach out to Alongo afterwards, and he has a whole team that can help guide you as well. Um, so with that, Alongo is our instructor today. I'm not going to introduce him a second time, but I do want to reach out and give him a thank you for the time to present and providing this audience with this opportunity to explore these AI tools. I can only imagine the hardships that come with entrepreneurship and the level of effort to develop these tools over the last several years. I know it's a bigger lift than I can think of. So I want to turn the floor over and to our presenter today, Alongo. We're all ears and hands. The floor is yours now.
Well, thank you, Tyson. Appreciate it. Well, thanks everyone for joining on the second day. Very excited for this one. I know this is a large group. We're going to stress test our platform today, so we'll see how can it, respond. And thanks for all the ones, all the people who signed up. And I think this will be very exciting. Kind of show what we can do. And I'm gonna put my email ID in here just in case if you guys want to reach out to me after this, or if you trouble with anything. I have a couple team members also stand by. If you have they will be monitoring the chat and make sure that if you run into any snag, they may be able to help you as well. But let me share my screen and you guys can stop me in the middle, Tyson, how fast I'm going or slow I'm going. And I'm also kind of mimicking the new user so that we are also kind of having the same issue instead of using my personal account. So if you haven't signed up, it's pretty straightforward. You can go to this aip.nia.ai and there's a sign up button, and all we need is your email ID. You can set up your password, and we will send an email confirmation email. Once you confirm that, then you are in. So when you log in, you're gonna see like this, or you will land on this page. But before I walk you through this exercise, what we're trying to do here is trying to leverage an agent. Can we build a 2D HEC-RAS model? And this will be a BLE model, so there is no structures or there is no very detailed modeling. So we just wanted to give you the project boundary and then create a mesh, and then the agent can pull down the right land use shapefile, the soil shapefile, and create the infiltration layer and set some boundary condition and go out to ping the no atlas 14 on the back end to create this 100-year, flood model. It's a very quick and dirty. This is just going to show you guys what agent can do. There is a lot of optimization we can do going forward, like, culvert burning or adding structures or refining your streams, fine tuning the mesh along the channels, optimizing your mannings and all those things. That's all coming. We're building those tools for our clients, but this is just a high level, getting excited about what agent can do, and set up a real HEC-RAS model, So that's what these instructions are. So if you have signed up, please sign up. It just take only like a minute. And once you've done it, I think a lot of people I see on the back end that you guys already signed up. So what we're gonna do is I have a GeoJSON file, which is the project boundary file. So if you click on that, it will provide you, where this area is located. So I will just copy this link and come back here. So this is a trial account, so you won't have all the bells and whistles, but very easy. What we can do is what we're going to do is we're going to create a simple project first. So if you go to the project tab, and this is just the filter. I will just, clear this one out. So And you can, create a new project. So this is, again, this is my new account. I don't have any projects. I wanted to see how the new user will experience this when they first come in. So I will create a new project, and then I will create this like ASFPM, um, you know, uh, workshop or something, whatever you guys want to name it. You can name it anything you want. And this time zone thing is like this is something that you can ignore this for right now for the exercise what we are doing. And you can keep the units as United States customary units. Also keep the spatial reference as 4326. Nothing has to change. Just name whatever you wanted to name, and then create this project. And what it's going to do is it's going to open up this map, and this is kind of just like a canvas of a plain canvas that you have. And you do have an agent right here on your right hand side. If you click on it, you should be able to see this. So you can provide like a thumbs up on the chat, like if you came to this spot in your exercise, like able to log into the platform and create a project, and then able to open up this near agent on your right hand side. So it will say like you're missing API keys. That's fine. You're not missing out anything so far. So on this left hand side, so I'm seeing everything is good. So we have a layer. So if you add a layer, it will show up here. But most of the time, what we're going to be interacting with the agent here. So far, so good. So you remember the copy, the GeoJSON, you have to click the GeoJSON file so you can actually get this URL. And I would copy this URL, and I will paste it here on the ask anything. I'm just going to paste it right here, and then I will just click submit. It's gonna say, hey, it founded the GeoJSON file. And what I'm gonna is asking for, hey, what do you really want to do? I found some kind of a shape file. What I'm gonna ask is like, hey, can you upload this layer to this project? And also, I want to create a HECRAS 2D model. So I'm just talking like a plain, like English talking how I wanted to say. And it's asking for, hey, what are the preferences that you wanted to, what are the things that you wanted to for? So I think Tyson, somebody asking for the GitHub link. So if you wanted to post that, I think that the link was somebody joined. So Tyson, if you can post that, yeah, that would be, thank you. So what I'm going to see is I want to create a HECRAS 2D model. I want to do 100 feet by 100 feet mesh. I want to do 100-year rainfall. And I'm going to say no culvert burn. So so it's saying like, hey, I will generate a HECRAS 2D model account first. This key authorizes the model. So again, it will ask for like a API key. It's asking like, would you like to create one for me? You can say yes. And it will create a simulation API key because you need this simulation API key. It will show this API key for you for your use for your thing. But right now, what it is doing is it's actually setting up the model at this point. And I didn't specifically say what kind of DEM I wanted to use, but I think the agent uses a lot of default methods like the SCS curve number, 10-meter DEM. But if you really wanted to test out 1 meter, then it would take more time to run on the background. But it has some default constraints that we provided. Go and grab all this data and then assemble it in a HECRAS file, right? So that's what it's doing. So it's going to take like a few minutes to. I mean, this is a smaller area, but here it seems like it's uploaded the layer. So if you click and zoom to a layer, it will zoom to this project boundary layer right here. And, you have, the satellite imagery on the base maps on here. And I will also set this project boundary. This is like the map extend. This will be your map extend. So if you refresh your project, it will load this. Space again instead of going to the United States, the entire view. So this is just a project view. So so this is a smaller area. You can see this is a real, this is a real city. It has done generating the model. So what I'm going to do is I'm going to download this zip file. So it will download this zip file. I'm going to open this one. You guys can do the same thing. It's a .zip file. You need to extract that one, and then we're gonna open that in a Hexgraph. So I do have first we will do that, and then we can also run this model in our platform. But I wanted to show you guys the platform, the Hexgraph model that we able to generate, and make sure that. So I'm using a 7.0.1, which is the latest version of Hexgraph. And I'm going to open up the new model that that I downloaded. This one, ASFPM Hexgraph 2D. I'm going to open that model. And then I'm going to open up the RAS mapper, and also I see some questions here. I'm gonna stop answering that. So Near is using like a multiple AI models on the back end. We use Cloud, OpenAI, and also we have open source models that we run, and be able to ping any of them based on the context of the problem that we are asking. So here's the Hexgraph. You have the terrain is pulled up correctly, and then I have the map layers. You have the land use. You can kind of see the soil, and then you can also see the infiltration. Layer. I can also kind of see this table here. If you don't like anything, you can, change that. So some of the default settings right here. So I wanted to see if I can, run this model. So I'm going to click on it. And let's say it's compute. It's running the simulations now. So what we did was we able to generate a very simple Hexgraph model. And the agent able to go out there and pull down all the data it needed and set up the model with error-free. So the AI, if the AI does not understand where the project boundary is, you can say, hey, can you use the project boundary in this project? Maybe it's not recognizing, it's looking for a specific project. So you can kind of say, hey, this project, specifically you can say project underscore boundary is the shape of the file, and then tell them specifically use this ASFPM, whatever your project name that you created, and that should probably solve your problem, Felix. So if you still have issues, let me know. So this simulation is done. So I'm going to close this one out, and I'm going to somebody asked, like, is the two agents can work together right now? So currently, no. Yeah. It does not aware of that, what other agents are doing. These are two independent agents. So, okay, let's go to the results.
Alongo, could I ask you a favor to
Yeah.
put the prompts that you've put in into the chat? So people could also use the same prompts if they want.
Yeah. What I did was I uploaded the file the first thing I had was this one. Do you want me to copy and paste in the chat or just to show this what I have here?
Yes, if you could just copy and paste your prompts, all of them into the chat.
Yeah, I pasted the link first, and then I add, so my first prompt is, can you upload this layer? Because I just copy and pasted the link first. And then I asked them to upload the layer. And then also I wanted to create a HEC-RAS 2D model. And then it's asked for what the requirements are. I just, created this. It says I need to ask the API key. I said, yes, please create the API key. And then it's setting up this type, mesh, design storm, inflow, culverts, downstream. And that's all it is. It requires. So, does that help, Tyson?
Yes, if you could just paste those into the chat. Oh, did you? Okay.
Yeah, I did. Yeah.
Yep. Thank you.
Yeah. So this is the results, right? And I mean, I know you guys saw HEC-RAS results here, but you can kind of pay this, and if they wanted to, export this layer, I can export this raster, and click OK. It's exported that raster, and go back. What API tools were called by the LLM during the process? Yeah, so it will go ahead and pull down all the soil, Surgo data and land use data. So we created our own API to go ahead and pull the data. We also curate a lot of data sets. We store it on our own server. And but we also go and ping if it's international data. Here, it's all mostly a standard land use data, standard Surgo data file. And we have a script that runs through how to create mesh. We are not using any HEC-RAS at this point. So this is all a custom developed script to kind of create the mesh, extend your terrain, go ahead and pull the terrain data from USGS. So this is all like several APIs the agent is connecting to. The boundary condition is still kind of very simple boundary condition, only one boundary condition at the end. But it's still kind of work in progress, but you can edit the boundary condition if you want, like, all around. But this is kind of the watershed divide. And it can create, like, if there is an inflow coming in, it will create an inflow boundary condition. It will go ahead and get the stream stats from, the QSs, it will create this temporal time series. So you can generate if there's inflow coming in, and you can modify it, but it gives you the skeleton of the model. But most of the simple model works. I saw, thank you. The scale is like, either like have 12 or something, like you want to keep it like the mess, like 500,000 mess or something like that. Don't overdo it, because the HEC-RAS has some limitations too. So at the county level, we've been generating this large scale, models. I think we feel comfortable with the, mess with this less than 1 million, or 700,000 cells or something like that. Around that scale, Okay, so the new project, they were asking how to create a project. So the new project is like, if you come here on the first time, you will have like this, projects. It's not the dashboard. It's the project you need to create. The dashboard is different. because you can kind of create like if you use .js dashboard, that's kind of similar to that. But the project is essentially you come in here under the projects tab and then come here to the new project and then type in whatever the name you want. And if you put the description, you can put the description, keep the same spatial reference. All you have to do is just the name. That's all it requires. Even if you don't put any name, it will still create a project. Even if I put like blank, it will create untitled projects, and so hopefully that. Uh, the mess issues is like we have a script that was a lot of things that we back and forth we fixed. Like you cannot have more than 8 sites and some restrictions on HackREST. We able to we have some restrictions, make sure that the mesh works in the HackREST. Yeah. Okay, so one of the things that I have is like sometimes the HECREST does not have the projection system when you export the raster. So I'm going to try it out and see. I exported this depth raster, so I'm going to click on it and I'm going to upload that raster into this. So this add data. So if you exported your raster, I'm adding the raster data here and I'm importing it. Sometimes the HackREST does not provide the projection system. If it doesn't provide the projection system, I wanted to bring it in QGIS and export them as the right projection system. So you can see like this is failed because it does not has that projection system. What I'm going to do is I'm going to add this raster in this my QGIS. Uh, missing the projection system. So I have to look at this projection system. Okay, this is N80-472 West Virginia. So we'll see if that's not, then maybe you have to find the right projection system. It's not the one. So hackers always have a little bit finicky. So Okay, there you go. I think that's what it is. So if you guys wondering, this projection system is ESRI 102751. So what I'm going to do is I'm going to export this, and this is also a little bit painful. Maybe you guys know the trick. I always have trouble with this projection system in HECRAS. So I'm going to save this as a depth raster. Okay. Okay. We got the layers now, so I'm going to go back to the platform. I'm going to delete this layer, the default layer that exported. So I'm going to upload the file, depth raster, and import this time. So we'll see. So that's I'm gonna answer some question. Mesh issues usually appear when you have break lines and refinement regions. Does AI help anyway to define break lines? If so, we have experience create model which does not run because of the mesh issues. I think I fixed a lot of mesh issues like the break lines, unless like it's just crazy break lines. So majority of the break lines in general, stuff works. I haven't run into any issues, so it does work, like refinement regions along the channel and the mesh, like a tighter mesh and all those things. So it does work. Um, so and is the AI mostly just orchestrating tools, or are there features where estimates are being produced? Yeah, so AI at this point, the agent is just orchestrating tools. The LLM kind of gives you some kind of like it just takes a lot of context away. So even if you say like create a HECRAS model, it will do it for you because it has a lot of context right now. We've been training the agent specifically for water resources, especially HECRAS, SWIM, and EPNet models, how to generate these models with a limited data set. So the agent has a lot of context. You have to provide in the last webinar, I talked about the skills and tools and everything. So a lot of the large language model Claude does not know like a very very specific about the water resource engineering side of things. So we have to teach the agent to provide the correct tools and everything. So it will produce, like if you import like a pipe material, let's say if you wanted to use some landing zone or even the land use, we have a criteria, but if you can find some, all of a sudden you find some land use that it's not recognized, you can make an educated guess, So the AI is smart enough to make some guesses, and if there is issues in model, it will try to fix some of the errors. We have done it in some of the scenarios in SWIM, and not mostly in HECRAS side of things. Is the agent basically populating the RAS mapper data? Yes, that is correct. I know we asked that, talked about that question. Can you please give me estimate of cost? I see the fees listed on the website, then it looks like there are add-on fees for computing costs. Curious how much computing costs are associated with model creation. Thanks. So that was the model creation. You're right. So this is actually setting up a small compute on the back end. That's what all this HECRAS orchestration goes on. So that's the cost that you pay for. So we charge by hour, and I think it's right now. I think we don't have any. We have currently right now like $1 per hour, but that can change. If we work with different clients and in a certain ways, like how big is your need. So that's customizable. But like at top of my head, like if I want to give you some cost compute, that's like $1 per hour. Does this currently have similar capabilities in coastal areas? Unfortunately, no. That probably something we can incorporate later on. There's not a lot of people reached out to us, but if there is interest to you, please reach out to me, and we can create those tools for you. how does the overall timeline, including both the data preparation and model execution, compare to running a standalone HEC-RAS model? So if I run this model here right now, this has the model. If I run it, it will take like probably like a 4 minutes or something, because HEC-RAS does not have a Linux complete, fully capable of Linux version. So we have to, unfortunately, we have to spin up a HEC-RAS machine on the back end, and it will run it on there. So the runtime on our is slightly longer because of the setup time. You need to install Windows, you need to install HEC-RAS, and you can install any version you want, and we can run it, and it produces the RAS, the depth raster, and then it will actually produces that. I'm going to produces that. Produces this raster, and then it will upload this depth rasters onto the project. So what we have done, like opening up the HEC-RAS model and generating the depth raster. So we fixed that issue in our platform. So it will run it, and then it will import the right projection on the rasters here. If I wanted to give a time, it's definitely faster than human engineer, I would say. So it's like as an engineer, it's just not fun to go out there and grab all this data every time you get a new client. So it's automating that stuff. So the upfront, you save a ton of time, and the simulation time, you're actually slightly a little bit higher. We're kind of trying to take that Windows out of the picture. We are having a custom Linux machines we are developing. Once that, taking the Linux machine we have, the Linux engine the HEC-RAS has, and optimizing it to creating the hydraulic table calculation, which is Linux does not do. So you have to run a HEC-RAS engine to kind of creating the hydraulic tables, especially when you create the mesh. So we are kind of testing 500 different models to kind of come up with some kind of algorithm to bypass that stage. Once you bypass that stage, you can run a Linux machine. That time it's going to be way faster. But I think I would say probably at this time you can save like 70% of the time, hopefully that makes sense. Can you explain again what projection was applied? I didn't have QGIS, so yeah. I can put it in the chat. So the projection system here is ESRI 26854 in West Virginia South. So I'll put it on here. It's EPSG. Okay, so it seems like file was loaded in the GIS. Okay, that's good. If it works, if you guys figured it out. What would be the cost to do what we just did if you just use it for processing input files, and you then modify and run locally and does that eliminate computation time? It still took like, I would say like 3 or 4 minutes. So you pay for that 4-minute computation, the assembling of the HEC-RAS, the computation, the running the simulation on your local machine. You don't need to do that. Then you can save like 3 or 4 minutes. You need to download the file and run it on your local machine. You can do it, but you still need to pay for the upfront assembling of the data. So that probably like a 3 minutes, 3 or 4 minutes, depending on how big is your model. So $1 per hour. So you're paying like a few cents. And Tyson, you can stop me anytime if you need any clarification. So what I did was, you can move up and down layer. I just moved down the project boundary layer so I can see the depth raster here, and then I also want to style it. So this is just default. It's going to say image. You can also kind of show it as a terrain if you want, this is kind of the water depth. I can also like upload the terrain that the model created that should have the right projection system. I'm going to go back and upload the terrain file here. There's the the default. So let's see if that pops up. So what you're seeing is the depth rasters, and I can also categorize a different way of seeing. This is I have a hill state and terrain, and I know the terrain is pretty nice. You can kind of see the terrain really cool. So I'm gonna change this one to just like instead of terrain, I'm gonna do like a graduated styling. You can kind of pick whatever, the number of classes. You can choose number of classes. Let's say I wanted to do like 4 different classes. I can choose the different, the colors here. Maybe, I want to choose this one. This is kind of like a bands. If you don't want this, I can change it to manual. Maybe I will, change this value to anything less than 1, and then I'm going to minimum is like 0.3. And this one, I'm going to do like a 1 and 3 feet. And this one, I'm going to do 3 feet. This is 5 feet. The last one, I'm going to do 5 feet, and then whatever the last value. So this is kind of a styling of your raster, and you can kind of see. You can also right-click your mouse. You can rotate if you wanted to kind of, do some presentation to your client. We also have these annotations. You can attach, videos. If you have a flooding, you wanted to show to your client, image or document, all those things you can kind of attach in this map. And then also, last thing you can do is when you upload this layer, we support all the different types of layer. If you go to the library, we do have a FEMA flood hazard. You can kind of click on it and then see what extent the FEMA effective floodplain is. And I'm going to, turn off this zone X because it's giving you everything everywhere, doing it. I'm just going to update this one, and then I'm going to move this layer all the way to the top so you can kind of see how this FEMA floodplain compared to the model we just created. So you can kind of see the FEMA flood map is this way, and you can kind of see the extent. So the the thing is, like, I had this the minimum is 0.3. If I eliminate this one to 0, it should kind of extend a little bit, but you can kind of see the picture. So it's not too bad, just some locations, the downstream, you can kind of see like this, and then also the extent of this floodplain map here, extend the whole watershed to. So this is like a large scale, very simple model. We are not fine tuning anything. So we did this like within I would say 10 minutes, it can create this stuff for you. And if you wanted to add a building's footprint layer, we also have a global building footprint layer from this company, and you can add that one. And you can kind of see the building's footprint. I'm going to move this one up. There you go. It takes 3 times. You can kind of see that, and yeah, so this is all the layers, rasters, servers, ArcGIS. If you want ArcGIS layer, you can also bring that in. You're going to compare the results, with what we have. So let me check the questions here one more time. I know we are 10:45. Can you upload an existing model and ask the agent to calibrate, given that we specify a clear criteria? Can it view our specification at certain profile lines and change parameters and rerun? Yeah, you can try that. We have a separate script for calibration, and you can also reach out to us. Most of the calibration we still leveraging the agent, but we would prefer to run it on a virtual machine. So this is your virtual machines that you can, spin up a virtual machine, and then you can, um, and this machine have a Python notebook, and you can run like a calibration, like you can run like thousands of simulations and modify, we have a RAS commander and all those things installed, so you can modify a bunch of stuff and run it and use our platform and then compare them and which model is the best. We have done it for swim. We ran like 10,000 models for one client in South Africa, and that's what the virtual machine comes in. So this agent is a one-on-one. If you really want like a big scale, like I want to run thousands of models, this is the criteria. We can definitely help you with that, and you can spin up, a simple CPU machine, and I can, if there is a interest, please reach out to us, and we have some case studies we work with the client. Um, can you download all the input files collected by AI for review? Yes. So the model is assembled and then give it to you in a .zip file format. So this is, so when you download the file, you're gonna create all this land classification, infiltration layer, and then the soil type, the terrain, the land cover, all this layer, the GIS data, the projection. So everything is assembled and give it to you in the .zip file. So you have that complete control over um, what is actually the AI is building. So that's what being an engineer is. You still have to review it, make sure that you're okay with all the curve numbers it assembled. You're okay with the boundary conditions. You're okay with the precipitation. You may want to check that plus 14, making sure that it's pulled in from the right, the frequency and all those things, by default, it uses a Atlas 14 temporal precipitation, distribution, but you can change whatever the distribution you want, This is also customizable. If you do have a better DEM or better land use, you can upload your own file. The agent will grab that file instead of the default file. So the agent kind of knows the priorities will be given to where the user provided data. And then if the data is not there, it will go and ping the data that we supported, so. Will responses to all these questions be published with the presentation recording? I think this will be recorded so you can go back and see it, I guess. I don't know if all the questions will be published. That's a Tyson question or Kevin question. I'll stop right there. It seems like everybody followed pretty well, Tyson, except like one or two hiccups, but most of the people not have any issues. And I know we have like 10 minutes reminder. We can talk about anything that's something that the committee wants. So
Yeah, so we'll leave 5 minutes. There's an announcement from the AI committee, and then I want to do the survey. So leave 5 minutes there. That gives us about 7 minutes right now. I'm going to
yeah.
circle back around the questions. I do plan on posting all the questions that were answered and the questions probably this following week or the week after. And then, we've created those flood zones in the LinkedIn to create the community. So if there's a question that was missed, or if you have a question that comes later today, later next month, feel free to add it onto that, and we'll continue the conversations outside of the webinar.
Yeah. And feel free to, put something in there. But we also have a street view. So if you want to like look at the streets, how it looks, it will open up the Google Street View at that location. And it seems like yeah, there you go.
So one thing I think we should mention is if people did have issues, like technical issues, or want to reach out to you, what's the best email or contact to do so?
Yeah, I put it on my chat. I can also put it on again. There's two emails there, so you'll go at near.ei or support at near.ai.
Then do we want to there's some questions. So there's the chat questions, then there's questions in the Q&A along. I don't know if are you able to see those and Or do you want me to start picking some?
Yeah, I got stopped by the asking for an API key. Yes, you can ask them to create one, ask the agent to create an API key, it will create it for you. Can you use this with ICPR4? We are, in the process of integrating, because we've been publishing a lot of large scale floodplain maps for, other parts of the world. They don't have a lot of good data sets. There's no floodplain, so there's a lot of requests there. So our team is thinking about integrating that. So definitely please reach out to us. We can help you integrate that. How do we get the $5 credits? I think most of us, you guys should get $3, and our developers online, he's going to increase that to a $5 credit for everyone. So you don't need to do anything. It should be available for you. So that can be checked on the settings page here. And if you go to the billing and there is this thing called user must have at least $1 to run a simulation. So I think by default you get $2 credit. So you see, like this is the account that I think somebody asked how much money we spend, right, for this compute. We spend like 5 cents or 4 cents. You can see like the free credit was $2. Right now my account balance is $1.95 or 96 cents. So we spend like 4.2 cents for the assembling the model. So you should get like by default $2, and we can increase that to like $3 more. So $5 you can play around with it. So I think our developer will do it on the back end. So you should see like $5 probably today at some point. So I have to drop off. Okay. Thank you. I have to leave for another meeting. Okay, that's all I have. I think. Did I miss any questions, Tyson?
We're going to stop early here, and I'll put the questions and we'll post responses to those questions online. I want to move over to the survey to give people a chance to
Yeah,
answer that.
sure. Yeah, I'll stop right here. Yeah, thank you everyone for this joining. I know you all are busy, so please feel free to reach out to me through my email or LinkedIn. I'm very active on LinkedIn, so send an email and we can collaborate. Appreciate it. Thank you.
All right, and I'll keep putting the survey link in here. So the purpose of the survey is to make sure we're going the right direction as a committee on these. Or, there's the 5 criteria there. And it also gives, so basically any input you put in is going to help shape what we do on the next webinars, who we invite, what we talk about, what we need to cover, what's kind of the criteria that we're going to use to evaluate future presentations. So please, everyone, open up the link that I've put into the chat and should only take a couple minutes real quick. And in the meantime, I'm going to turn it over to Fetmano here, who's going to give some announcements for the AI committee.
Thanks, Tyson. And also thank you, Elenko, for your demo and also for the webinar on Tuesday. This is very, very helpful. It's great, participation and engagement here. So for everyone, thank you for joining this ASFPM AI Committee webinar. We really appreciate your time, your participation, and interest in exploring, this AI and floodplain management, right? So this webinar is a part of our ongoing effort to build awareness, to share knowledge, and foster this kind of discussion, thoughtful discussions about the benefits and risks, and also responsible adoption of AI, particularly across our membership here at the ASFPM. So we look forward to bringing more this type of webinars and demos and resources and any opportunity in the future. So as many of you know, that the ASFPM board elevated us from the AI subcommittee under the higher educations committee this year to a new now established standing committee. So we are currently, the team here, the committee leadership here is working on to create a new web page for the committee, and also to set up the portal so you connect with us directly. So look forward to that. In the meantime, we say many times, stay connected and continue this kind of conversation by following us through the ASFPM AI LinkedIn group that we share, the ASFPM AI Collaborative, I believe, and a lot of people have been signed up, and great to see that. And also the ASFPM flood zone platform. I think we try to build that. I know there's some step for you to get there, and start with a LinkedIn, and then eventually we would slowly, import everything to the platform. It's really help us to share all these kind of more detailed files, and we have the file system that we can share across members and organizations. So, and feedback, let us know what kind of topics, speakers, use cases, so anything related to AI challenges that you encounter. We would love to to find a way to address in the future events. Okay. That sort of, just want to kind of emphasize that, and thank you for being part of this growing community, and looking forward to kind of for the future event, and have a great afternoon.
All right. Thanks everyone for joining, and I hope to see everybody in a couple months from now with the next one. Bye.
Thank you.